To understand point of inflection, we need to understand how gradient changes when when it is positive gradient and when it is negative gradient. For example, when it is positive gradient, you can see that as the line goes up, it is mathematically called. So as line is going up, mathematically called steep, as it becomes steeper, the gradient increases. I think this idea is pretty much straightforward. Whenever gradient is positive, as you steepen it, then the gradient increases. On the other side, when the gradient is negative, whenever the line is going down, the gradient is negative. If you can see here, the red color one, which is negative 0.1 slope, and the next one negative 0.5, as gradient decreases, pay attention here, negative 0.1 to negative 0.5 to negative 1. On the negative side, as value increases, as quantity increases, value decreases, isn't it? So here, as it steepens vertically, the gradient decreases. Here, the gradient increases as it steepens, and the gradient decreases as it steepens. Okay, other way around. If you are going down in this way, then the gradient increases. This idea should be pretty much clear in order to understand the behavior of the tangents on the curves when we do stationary points, point of inflection, and that stuff. So we'll go to the next um, slide here. For example, you can see this is point of inflection. This is point of inflection. This is also point of inflection. Let's try to understand the nature of the tangents before the point of inflection and after the point of inflection. Before the point of inflection, if you see, this is positive gradient. So you always see from left to right, remember, you always see from left to right. As you see left to right, the gradient decreases and it becomes zero here. It becomes a flat line. There is no gradient. It should, when it is a flat line, there is no rise here. So gradient is zero. And after it becoming zero, again, now if you see, the gradient is increasing here. Here the gradient was positive, but it was decreasing. Here the gradient is positive again. Gradient is still positive, but it is increasing. In conditions, if you remember, concave downwards and concave upwards. Here this is concave downwards, this is concave upwards. Whenever you know that it is concave downwards, or whenever you know that there is point of inflection, before the point of inflection, if you know that that is decreasing, meaning second derivative d square y by dx square is less than 0, here d square y by dx square is greater than 0. This is the condition. We will go through the condition again, but at this point of time, what you need to understand is the curve changes its concavity compared to before the point of inflection and after the point of inflection. Here also you can see that the gradients, this is negative gradient. So as it becomes flattens horizontally, the gradient increases. Gradient is negative, but gradient is increasing. It becomes a flat line. Here also gradient is negative, but it is decreasing. Gradient is negative, but it is decreasing. You can also see that before the point of inflection, the concavity was upwards. Here concavity is downwards. Now, as you know this one, you always say that d square y by dx square is greater than 0. And here d square y by dx square is less than 0 because it is decreasing. So we will discuss about this meaning shortly. Now, there is a small activity. For this activity, take 1 minute and make sure that you try the questions before I discuss the solution of this. See, so you can pause now. I hope you have paused and you have tried these questions. The section curve has a gradient initially positive. The gradient is increasing as x increases. The gradient is increasing, if you see, gradient is increasing as x increases from left to right. You need to sketch the curves. If you haven't done before, even now you can pause the video and you can try that. You need to sketch the curves with the following properties. Gradients initially negative. Gradients are initially negative, it is going down, and gradient is increasing. Gradient is increasing. It should be something like this. In order to increase a gradient, it should be something like this, isn't it? This is the way it should be. Becoming lesser negative or going from negative to positive. So this one becoming lesser negative. So the curve would be like this. And now B part. Gradient is initially positive and gradient is decreasing. Gradient should be positive. It should be something like this. But as you go down, the gradient should decrease. So it should be something like this, isn't it? So then only the gradient is decreasing. This is the diagram for B part. And the third one, gradient is initially negative, it is going down, and gradient is decreasing. Gradient is initially negative and gradient is decreasing. So it should be going down. As you go this side, it should straighten up. So when you go from left to right, for example, something like this. So it should straighten up. So if you see, the gradient is negative, but it is becoming even smaller. It is becoming even smaller. It straightens up. So this would be the curve. This is C. Now, the the two curves with increasing gradient, you need to describe the shape. So increasing gradient, so if it is increasing gradient, this one, it is concave upwards. This one is A. This is also concave upwards. Gradient with decreasing gradient. These two, B and C, both are decreasing gradients. So if you see, that is concave downwards. Concave downwards. Okay. Make sure that you understand this and you can go back and watch it again in case if it is not that clear. Now, next one. This is the main part to understand how to sketch the graphs based on the given information. Whenever you have a question, they give you y and you change that to, you find dy by dx. The moment you have y, you always find dy by dx. And then it could be possible that dy by dx is equal to 0 or dy by dx is not equal to 0. Let's go in this direction first. If dy by dx is equal to 0, these are called stationary points. These are called stationary points. If they tell you that it has stationary points, you write this one, you equate that to zero. You equate dy by dx to zero. Okay, if you're finding stationary points, you equate dy by dx to zero. And then stationary points can be three different points. It can be a minimum point, it can be a maximum point, it can be point of inflection. It can be point of inflection. When it is a minimum point, the curve would be like this. The curve would be like this. See, dy by dx, if you see this one, when the curve is like this, at this point, the gradient is zero. That's what dy by dx tells you. At this point, dy by dx is equal to zero. That's why it has a stationary point. Point of inflection, it would be like this, or it would be like this. You can also see if you draw a tangent here, again the gradient is zero. That's why when it is stationary point, meaning at a particular point, if you draw a tangent and if you find the gradient, that is equal to zero. Here, also here, also here. Now, in order to know if it is a minimum or maximum point, you need to take the next point immediately as much close as possible, and you again find the gradient. As you are finding gradient for the second time, d square y by dx square, if that is more than zero, meaning it is going up. So the next point is going up, meaning this is a minimum point. If d square y by dx square, what is the meaning of that? The point immediately next to this point, the stationary point, if you find the gradient at that point, it is less than zero, meaning it is going down. In this case, you can see that even the next point, if you take d square y by dx square, think about it, what it should be. Equal to zero. Here also, d square y by dx square equal to zero. So in short, when dy by dx is equal to zero, that point on the curve, at a point, if dy by dx is equal to zero, it could be a maximum point, it could be a minimum point, it could be a point of inflection. But in order to know if the point of inflection is in this, if the curve is like this or if the curve is like this, there are two ways. Either you find third derivative and find the behavior of the curve at that point, or you take a point just before. So whatever the point this is, let's say x equals to 2. You take a smaller value than x and you take a bigger value than x and you see the nature of it. Okay, we will discuss that shortly. In order to decide, so these two are straightforward. Directly they tell you minimum or maximum. But here you need to know if the curve is like this or if the curve is like this. This part, when dy by dx equal to 0. When dy by dx is not equal to 0, then you again find d square y by dx square. You again find d square y by dx square. If that is equal to 0, meaning this has point of inflection. Point of inflection, meaning the meaning of this is there is no, so the curve would be like this. The curve would be like this, or the curve would be like this. So when you take, if you see, there is no horizontal tangent here. There is no, you can't, if you draw a tangent, that would be something like this. If you draw a tangent, that would be something like this. There is no horizontal tangent you can get. For example, here, if you see, I'll change the color. If you see here, you can get, if you draw a tangent, that would be like this. But here, you cannot get a horizontal tangent. But if d squared y by dx is equal to 0, then it has point of inflection. So dy by dx is not equal to 0, but d squared y by dx square is equal to 0, meaning it has Here, this is stationary point of inflection. Then obviously the second name, this is non-stationary point of inflection. Non-stationary because never there was dy by dx equal to 0. Never there was a horizontal tangent. Okay. Now, so this is all about understanding how point of inflection works. If you're not sure, I would recommend to go through again. And if you have any questions, you can ask me in comments.